I have 6 days to make a menu system for my NES emulator. A menu system needs to at least let the user choose a ROM image, change the size of the window, and set up the keyboard and gamepads. But first I needed to rename the main file of each front end. Neither From Reset nor FBI example makes a bit of sense outside what you've seen of the making of family size VM. I added redirect shim files to keep things building across a pole. It's still compiled. Next I loaded a font for the SDL frontends menu. I'd keep the upscaler textures in a struct called the output context. I added a way to tear down an output context when done. I moved the output context setup from main to an init function. At least this way I didn't need goto to tear it down. I ported the rest of main to use the output context. It made main's teardown 4 lines shorter for both success and failure. Everything was working again. Just as the NES has a name table to store its text, the menu has a name table that maps character cells to glyphs. Both the palette and the font are 1,536 bytes. For the font, that's 16 bytes per glyph times 96 glyphs. I cleared the name table at program startup. I wrote a loop to draw the menu on top of the emulated NES screen. It's called OSD in the source code. That stands for on-screen display, like the menu of a TV. The loop is nested by a factor of 4. Rows of tiles, tiles, rows of pixel in the tile, and pixels. Like NES tiles, menu tiles are stored in 8x1 pixel groups. I've called these slivers in other spaces. I added a shadow to the glyphs to make them more legible. The menu drawing loop didn't crash. Next I tried writing text onto it. That one crashed and got caught by the sanitizer. I had the row and column counts transposed. Fixed. I moved the menu drawing loop out to its own function. That was painless. I started refactoring storage for the menu state. I looked up a function on CPP reference that I'd be using to copy strings to the menu's name table. What makes strncopy useful is that it pads the string on the right with 0 bytes. This helps clear the previous contents of a line of text. I could draw a line of text and a frame count over whatever NES game was running in the back. I had text, but not yet a cursor. "5 days to make menus, 5 options in the menu. I decided to wrap it in a state machine. This state machine would own the menu name table. Each state would have load and run functions which would call convenience functions such as clearing the screen. I decided on what states I wanted. I refactored main to use the menu state machine's name table. The menu would need press detection and auto-repeat logic. Only directions would be auto-repeatable. I populated the About box with multi-line text and filled it with an appropriate copyright notice. First I added switching between the top menu and About box. I called the state machine from main. Hidden is a state, just like top menu and About box are states. I started on a hook for operating the menu with the mouse. I put that off for later. I called the appropriate run function for the current state. I made this menu compile. And it had an About box. Next I needed to forward buttons to the menu while not hidden. Again, scan codes are better to have things in the same spot between keyboards in different languages. I hard-coded pressing the escape key on the keyboard to sending a select button press to the menu, as well as other keys so that the player could still operate the menu to reconfigure the controller. I could toggle between top and About but not hide the menu. That's better. I had top, About, and hide. My priorities weren't quite as I had expected. I needed to prove to myself I could make a menu in the first place. I added the tinyfiledialogs library to the build and read up on how to call it. Actually calling it would wait for tomorrow. "4 days to make menus. 4 options left in the menu. I heard back from 100th Coin, who had a few theories about why Accuracy Coin was freezing. That would have to wait. I had a file dialog to try. The file picker ran, though the ROM was still from the command line. I added a file name filter for only NES ROM images. I added a way for the menu to pass a ROM file name to the core. But first I wanted to let the user move a cursor up and down to one of the 4 rows of the menu. B button or escape to hide, A button to choose the item by calling the item's load routine. The cursor was moving and choosing the About box. I made the start button or return key choose the item as well. I checked for updates to give my brain a 2-minute breather. While that ran, I read through the tinyfiledialogs source code to look for the lifetime of the chosen file name. I ended up on a variable whose name looked like a line buffer. I found it as a static array belonging to tinyfd open file dialog. This meant the lifetime was until the dialog was shown the next time. When the user opens the dialog and then cancels it, that could overwrite the file name. So I had to ensure I used the file name only briefly, setting the variable to a null pointer once I was done with it. And while I was thinking about it, I made window size a variable. I sized the scale variable in units of 50% and passed the scale when creating an output context. I had it load the ROM chosen in the file chooser and factored that out to a function so I could document the return value's lifetime. I called the file chooser only if no ROM was given on the command line, and moved the error message for no ROM after the user cancels it. It loaded the ROM I chose. I added an item to the top menu to choose another ROM. This meant I needed to move loading the ROM into the main loop and prepare to unload the old ROM after loading the new one. And it gray screened. I acknowledged the request to load the ROM. It was behaving a little like an interrupt in that respect. Would it load 4 ROMs in a session? Yes, it did. My next task was to change the window size. When the user points at zoom on the top menu and presses left or right, it would remake the output context. I had it show the current size in 50% units. I limited size to between 100 and 800%. The first step of scaling needed to round the factor to a whole number. I added resizing to the main loop and closed the emulator if resizing fails. And zooming was working, just in time for me to wrap for the day. Three days left, 2 controllers, 1 task left. I decided how to represent a button binding as an integer. This could be a keyboard scan code, a button, an analog axis, or a digital axis. That way, instead of hard-coding bindings, I could make them editable. I refactored reading buttons into a function. One step at a time, I made sure the refactor worked before I added customization. It was complaining about the default bindings being unused, so I populated that. I passed the result from SDL having read the keys, and once I had 3 arguments, I felt compelled to document them. No change as expected. I put the current bindings in the menu state struct because the menu would be editing them later on. I thought about how to encode a binding as an integer. One step at a time. Start with keyboard only. It was using bindings from the array. I only needed to edit the bindings and that was it. I'd need 2 rows on the top menu, one for each controller. I started on the load and update routines for a control viewer. Both controllers would use the same function. I decided what order I wanted the functions in, and after a renal flush, I decided to put text layouts next to functions for the moment. I divided the screen between the bindings' names and values and wrote a function to draw one binding. I read the SDL manual for what bindings are possible and how to get the name of a key. I made the changes compile. Even though C isn't quite Rust, GCC can still pick up some buffer overflows at compile time. It was showing binding names, leaving values next to draw. While I thought of it, I fed controller 2 input to the core. There were the values for both players. I tried it in 240p test suite's input test and it was reading all the buttons for both players, but the select button was opening the top menu. I had it explicitly block that if hidden. That was an improvement. I realized I also needed to keep the game from seeing the button that was pressed to hide the menu. I designed how that might work. If a button is held when the menu hides, don't let the game see it until either a fraction of a second passes or it's pressed again. I'd have to finish that one tomorrow.